Hello everyone and welcome to our YouTube channel IKY Science. In our randomly released videos, we will be discussing various topics related to technological and scientific areas such as space, astronomy, physics, engineering, chemistry, computer science, artificial intelligence, future innovations and gaming. So stay tuned, subscribe to our channel and keep supporting us. As you know, our last video was about thorium, but today we will discuss about a different element which is known as astatine. Mm, in 1869, when Mendeleev published his periodic table, as you all know, there was a space under iodine, and after the Danish physicist Niels Bohr established the classification of the elements, it was suggested that there might well be a fifth halogen. As you know, astatine is a halogen. For a time, this was known as eka iodine, from the Sanskrit eka meaning one, referring to the element one. This element referring to the element one space under iodine. Okay, chemists attempted to find this elusive element in nature without any luck until it seemed 1931 when a group of scientists led by Fred Allison in Alabama, USA claimed that they had isolated eka iodine. They gave it the atomic number 85, as you all know, and called it alabamine. However, their claim was disputed after other scientists failed to recreate or reproduce their processes successfully. As you all know, scientific theories must be reproducible. So let's check these properties. Here we can see that the atomic number is 85, and it falls under the halogen category. Atomic weight is 210, and its phase is solid. Melting point is 302 degrees Celsius. Boiling point is 337 degrees Celsius. The color is unknown, and crystal structure is also unknown. So basically, we know very little about astatine. Mm, the element was finally isolated in the 1940 by a team at the University of California, Berkeley, USA, including Dale R. Corson, Kenneth Ross Mackenzie, and Emilio Segre. As we move into the next slide, we will see here you can see he was the inventor. He was the discoverer of the element astatine. His name was Emilio Segre, and he was an Italian physicist who had escaped from fascist Italy during the World War II. They isolated they isolated they isolated astatine by bombarding bismuth with alpha particles in a device called a cyclotron. We will see it later. So this cyclotron, a form of particle accelerator. However, this team could not continue its research due to the Second World War and the demands of the Manhattan Project, the US government's research project that developed the atomic bomb. So much of the research was based at that time was uranium. So since then, research into astatine and its properties has been difficult due to its slightly reactive nature. So let's see about its half-life. As you can see that the most stable there are many isotopes of astatine, but three are prominent, which are astatine 209, and the astatine 210 and astatine 211. As you can see, the most stable isotope is astatine 210. It has a half-life of 8 hours, so it is the most stable isotope of astatine. And the others here are astatine 209 has a half-life of 5 hours, and astatine 211 has a half-life of 7 hours. So astatine completes the halogen group and shares some of the characteristics of its fellow elements. It is highly unstable, as you all know. It is a radioactive, very radioactive element, and it is highly unstable in its natural form. Its name was derived from the Greek word astatos, which means unstable. So the name itself means unstable, and like iodine, it will vaporize quickly at room temperature. Astatine is heavier than other halogens, which is what makes its melting and boiling point higher than the rest of the group. Many of them have been estimated based on the element's position on the periodic table as a heavier analog of iodine and a member of the halogens, the group of elements including fluorine, chlorine, bromine, and iodine. Astatine is likely to have a dark or lustrous appearance and maybe uh, a semiconductor or possibly a metal. So as you can see, we do not know much about astatine so far because no one has seen it. Yes, astatine was once thought to be the rarest element on Earth. However, it has lost this status to berkelium, which has to be produced by neutron capture and beta decay in uranium. Astatine is one of the rarest elements on Earth, naturally occurring rarest element on Earth, which is not a bad thing considering the fact that it is highly radioactive. It is the rarest naturally occurring element in the Earth's crust. So, um, you will be surprised to know that quantities of astatine on Earth are estimated at just 28 gram at any given time, and the half-life of its longest lasting isotope, I showed you earlier, that the half-life of its longest lasting isotope astatine 210 is just 8 hours, as you can see. So such characteristics create a huge challenge for the research chemists because as a result the pure element has never been seen by the naked eye. Appearance, so astatine's appearance is unknown. Probably it is probably metallic. Only tiny amounts of astatine exists in nature as part of the decay of uranium and thorium, and the element has no biological role. Cyclotrons, uh, it was discovered using a cyclotron. As you can see here, that the two physicists standing near a cyclotron during 60 or 50 years ago, and he was a famous physicist and he won a Nobel Prize in physics. His name was Ernest Lawrence. Okay, so this is a cyclotron. As you can see the name here, this is a cyclotron. So cyclotrons are the early design of particle accelerators in which charged bodies such as protons and alpha particles are accelerated to high speed by electric and magnetic fields. So we have learned a lot about astatine, but only tiny amounts of astatine exists in nature as part of the decay of uranium and thorium, and the element has no biological role, as I told a moment ago. Uh, the isotope astatine 211 has found its use in recent times in radiation therapy for cancer, in particular prostate cancer and melanomas. However, once the astatine is produced, it has to be used very quickly due to its short life, half-life. Like iodine, astatine is collected by the thyroid gland in the neck. Astatine 219 has a half-life of 56 seconds. So as you can see, 56 seconds. One of its isotopes, Astatine 219, has a half-life of just 56 seconds, and it is also the longest lived of the naturally occurring isotopes. Mm, Astatine was first produced by bombarding bismuth 209 with energetic alpha particles, and this is still the major route used to create the relatively long-lived isotopes, just like astatine 209 through 211. So in the last section we will see that um, here you can see that this is autunite, a fluorescent uranium mineral whose decay can produce an atom or two of astatine. So you can guess how rare it is, astatine. So thank you guys, that's all for today. Be sure to like, comment below and share. I hope you enjoyed today's video. So subscribe to this channel and help us to grow.